Grade 12 learners, we are working through another analytical mechanical activity where 3 views and 2 detailed enlargements of a tapping valve assembly has been given, a title block and a table of questions. The drawing has not been prepared to the indicated scale as provided on the drawing, but you need to complete the table below by answering all the questions related. What is the title of the assembly? And that is going to be tapping valve. Question 2. On what date was the drawing drawn? So we go down to the title bar and the date was on the 5th of the 1st 2015. So that's the 5th of January 2015. Question number 3. What is the drawing number? So we scroll down to the title bar and we'll find the drawing number right here. 2015-A-005. Question number 4. What scale is indicated on the drawing? We find the scale right here in the title bar and that scale is 2:1. That means everything needs to be doubled. 2:1. Question number 5. Which drawing program was used? The drawing program was AutoCAD 2015. Which was used to process this particular drawing. Question number 6. Who approved the drawing? So here in the title bar you will find the various people involved in the tapping valve. Drawn by Chris Legreef, checked by Soon Denton, but the person that we are looking for is Andrew Brand, who approved the drawing. Question number 7. What material is used to manufacture the main base? So we scroll down to the title bar where you will find a part list and there are 7 parts of which number 4 is the main base, and if you move across the material is pewter, and that is your answer to that particular question. We look at number 8. What would view 2 be called? So we find view 2 here and we find view 1 on top of view 2 and we find view 3 on the right hand side of view 2. Your front view is situated so that the top view, which is view 1, is above that view. Hence it is classified to be the front view. But it comes with additional information. The fact that it has been hatched right from the start to the end on this side, it means that it's a full section front view. So your answer is a full sectional front view. And you will find that it has been cut right here, of which this part has been removed. It shows all the parts which made contact during the cutting process. Question number 9. How many socket head bolts are there in the assembly? You scroll down and you consult the part list again. You will find that component number 2 refers to the socket head bolt and the quantity would be 3. So 3 would be your answer. Number 10 requires the complete dimensions at A, B and C. Let's have a look. Now if you look at where A stretches from this point to that point, and it refers to the inside line here to the inside line of that side, not the outside. It cannot be M5 because M5 refers to the outside points. From outside to outside it will be 5. So once you have M5, it means that there is thread on this side and thread on that side. So how do you calculate the thread? You take M5 times 0,1 and M5 times 0,1 gives you 0,5, which is literally a half. So the thread part here is 0.5 millimeter and on this side it is 0.5 millimeter, and having half and half is 1 millimeter subtracted from the 5, which means that the inside part will be 4 millimeters or diameter 4. If you look at B, B refers to this part over here, which is the head part of this bolt. And if you scroll up, you will find that the circle is the reflection of this part here, and that circle is diameter 4 or 4 millimeters as an answer. So if you look at C stretches from here until this point over here. What you need to do is to find C in a different view. You cannot find it in your front view, your sectional front view. You will be able to find it in your right view, which is view 3, and you will find that C stretches from here to there, which is 26 millimeters. Number 11, name the feature at F. So F can be a fillet or it can be a round out. A round out is an example of a fillet. So fillet and round out both will be accepted. Number 12, name the type of section at D. Here you find D in one of the detailed drawings, and D refers to a specific part that needs to be shown, hence the wavy line, and you know that part section is synonymous with a wavy line in detail, so the answer to D is going to be part section. Number 13, why is the component at E filled in solid? So if you look at detail S, there are two solid parts shown, and that is E, which we are looking for. There are two reasons why this has been made solid. The one reason is that it could be rubber as one of the components, and you will see it being indicated here as an O-ring or an O-seal, both of rubber. That is the one reason. Alternatively, it could be that the area is so small that it cannot be hatched, hence that we just merely color in that section. So rubber or too small for sectioning. Number 14, what is the total height of the assembly? You will find the height in your sectional front view, and it has to stretch from here on top right up until the bottom part, which is this part over here. You will see that it drops from here down to that point as 22 millimeters, but it has 4 millimeters only until that point there. But if you look at this radius here from that center point to that arc over there, you will see that it's 7 R7, and R7 plus the 22 that you will have there will give you 29 millimeters as the total height. If you look at number 15, what is the purpose of the two enlarged detailed views? And here they are clearly referring to detail S and detail T. It is merely to show more detail. Number 16, what is indicated by the convention at G? G refers to this symbol that you will see here on the end of the shaft, and it appears here on the other side as well. That is called an S break because it takes the shape of an S. So it's called an S break, which is your answer. And the function of an S break is merely to indicate that the shaft continues. Number 17, with reference to the tolerance, determine the maximum dimension at H. So here we have H, which has a dimension of diameter 6. The plus refers to the maximum, which means you have to plus 0.35 to the 6, which will give you an answer of 6.35. You have to write the entire calculation down to be able to attain the 2 marks. 6.35. Number 18, with reference to the tolerance, determine the minimum dimension at H. We are back at H, which is diameter 6, and the minus refers to the minimum tolerance, which is 0.53, which means that you need to state 6 minus 0.53, which will leave you with an answer of 5.47. 5.47. If you look at number 19, insert the cutting plane in view 3 and label it as AA. So here is view 3. And all we need to do is find the center line which is there and convert it into a cutting line. When you are going to do that, you need to highlight or darken the end longer lines, and you need to have an arrow that faces away from this drawing to the line, which is going to be situated on this side of the line. And the reason for that is that this part is removed, that part remains, which shows this cutting section that you will see here. So the arrows will be similar to this arrow here, and it always takes the side of the section view, not on the opposite side. And please label it as AA, and that will score you 3 marks. And finally, number 20, our favorite question. In the space provided, draw in neat freehand the symbol for the projection system which was used. And that projection system will be indicated in this space where it says answer number 20, of which you're going to start with a center line, short, and 2 long lines on the side for half a mark, small circle half a mark, bigger circle half a mark. You will have a representation of the small circle in a line format for half a mark, the bigger circle representation for half a mark, and the 2 connecting slanted sides, which will give you another 2 half a marks. And the final half mark will be allocated for the drawing being freehand, equating to 4 marks. Grade 12s, that concludes our analytical mechanical activity for this week. Please ensure that you filled in all the answers as we made our way from 1 to number 20.